Hi, good afternoon, everyone. It's nice to be here. I submitted the abstract of this paper out of the blue, right? Because this is actually a working paper, my working paper for my Master of Education degree in mathematics. So basically, why is it that I picked this study? At first, actually, I wasn't interested about conducting a study with Korean respondents, but I'm very interested about the cultural underpinnings about mathematics. There are so many studies that keeps me amazed. Why is it that Japanese are doing well in mathematics? Why is it that Koreans are doing well in mathematics? Actually, Asians are tagged to be good in mathematics, except for Filipinos. Right? So that's why, in the context of mathematics, Filipinos are not Asians. Right? So, yeah. So, if you're Chinese, you're good in math. If you're Korean, you're good in math. If you're Japanese, you're good in math. Right? If you're Malaysian, somehow good in math. But Filipino, not really. But actually, it's amazing also because if we're going to look at mathematical competitions, international mathematical competitions, Filipino counterparts are really doing good. We've been winning in International Mathematics Olympiad. Our representatives, but most of them are Chinese, right? Chinese Filipinos. Yeah. So there must be something. There must be something with culture that makes one good in mathematics. When we talk about culture, it could be the language, it could be our value system, it could be about how we view things, so many things. So, however, after Dr. Lee, Dr. Capistrano, and Miss Mia evangelized UP Cebu about the UP Korea Research Center, I became interested. Why not? Instead of looking at the cultural perspectives of mathematics in the Asian perspective, why not shift the study to Koreans? So after their talk, which was in August 10, I had to revise my proposal, and my advisor, my professor, also liked the second proposal, which was all about the Korean. And another thing is that I'm working in an international school wherein 10% of our population, around 10% of our population are Koreans. So why not capitalize on this and try to understand what is really these Korean high school students, what are these cultural underpinnings or cross-cultural experiences that they go through when they study mathematics here. Because I have noticed that, I don't know if they were randomly or purposely sampled, but basically most of the Korean students in our school are really doing good in mathematics. Right? And they come to the classroom with a different way of doing things. Right? So for the past years that I have been teaching mathematics in a multicultural classroom, I have noticed that some students have really their own ways of doing things. That's why Dr. Eric asked me earlier if it is possible to apply the constructivist approach in mathematics, because basically mathematics was always an absolute answer, right? You cannot ask for an opinion. Or what is 1 plus 1, right? What is 3 plus 4? Okay, so we always say 3 plus 4 is equal to 7. However, yes, we can apply the cultural way, or the constructivist approach. Why? It's because although there is only one absolute answer, there are so many ways of looking at it. For example, the number 5 can be looked at in so many different ways. You can look at 5 as 4 plus 1. You can look at 5 as 5 times 1. You can look at 5 as 3 plus 2. The way you would look at the number 5 would depend on what you're feeling right now. Right? So maybe if you're feeling something that you have this sense of identity right now, right? So maybe we will look at 5 as 5 times 1, the identity property. Right? So it depends. So mathematics is actually a very creative, a culturally driven subject. Now, in the old times, I understand that our ontology of mathematics is driven by the fact that in the old times, our professors or our teachers would always say that there's only one way of doing it. If the solution is not the way how I want it, that's wrong. right? Even if the answer is correct. Right? I remember when I took up engineering, our professors would always help us follow all the steps. If we miss one step, our answer is wrong already, even if our answer is right. Okay, that was actually the traditional view of mathematics, but it has already changed. So now, yes, this is the school. This is the environment of the study. This is where I'm teaching right now. And when I conducted further research about Koreans in the Philippines, especially high school Korean students, I found out that there was this trend in Korea called the ESA, or the Early Study Abroad. Okay. This started way back in 2007, and actually we will be able to see it as a trend because in 2007, I guess there were more than 400 Koreans only were given the SSP, the Special Study Permit in the Philippines, and it rose to more than 3,000 the following year, and then the year after that, it went up to around 4,000, but most recently it dropped again. But the drop is not really that drastic. But if you are going to compare the rise of the number of high school Korean students who are studying under the Special Study Permit, it was really very drastic. Okay, why? So yes, so this is actually in a study that was conducted by Law. She cited that the early study abroad destinations in 2008, in which the top is the United States, and then followed by the Southeast Asia, and then Canada, and then China. So of course, and number one in Southeast Asia is the Philippines. So, and we are talking about high school students, okay, elementary, middle school, and high school students are coming here to study. Okay, so these are the common purposes why they come here to study mathematics. First, to learn English, of course, as foreign language, or to improve one's employment prospects, because employment in Korea is very competitive. Right? If you don't have the skill, you won't get hired. Okay, so now, of course, some of them, they would like to escape the education system, and it's focused on the college entrance examinations because of the the grueling education system in Korea. So I have noticed that this is typically true. Especially that I have noticed that there are some Korean students that we have that they're just very chill. The exact opposite of the good Korean students. So maybe they're the ones who come here for a more chill education. So they would also like to escape the high cost of private tutoring in Korea, and to gain an edge in college admissions and other reasons. So according to Law and Lee, so these were separate studies that were conducted in 2015 and 2017. These are the common reasons why Korean high school students leave Korea and decide to study abroad. So first, the intense competition to enter elite universities and to secure decent jobs. So because of that, they would rather go to universities abroad. And for them to be able to get into universities abroad, they need to have good English skills. And how would they acquire that? By starting early studies outside Korea. So, and at the same time, South Korea's rapid economic development and the continued pursuit for globalization of Korea is one of the determining factors or motivations why a lot of Koreans come here to study, especially high school. Okay, so now in this study, I also look into the influence of culture in learning mathematics. So in looking into the influence of culture in mathematics, these are the two prevalent theories learning that tells us that there is really cultural variation or cultural differences in learning mathematics. Because for example, recently, we were laughing at one of our reference books in modern algebra because it started with chapter 0. Right? This very weird, yes? Since time immemorial, we always start with chapter 1, but this book had chapter 0. Why? The author is coming from Canada that recognizes 0 as a natural number, as a counting number. For us Filipinos, we start counting at 1. For them, they start counting at 0. So 0 is a counting number for them. So that's a cultural difference. So it is not true that mathematics is universal. Right? Some concepts in mathematics is universal, but mathematics as a whole is not universal. There are variations. Okay? And these variations are brought about by cultural the cultural underpinnings in the study of mathematics. So the social constructivism theory by Lev Vygotsky, basically according to Vygotsky, learning or knowledge is co-constructed. We construct it together with our peers or with our teacher, and that's the reason why we have conferences. Right? In mathematics, we have conferences. Why? We have to agree. All mathematicians have to agree that this is the right way of representing this variable. Okay? So why is it that we use X? Why do we use A, B? In algebra, we use X, Y. But later on, if you do higher mathematics already, A will be used already to denote an arbitrary variable. So these are all conventions. These are all agreed upon conventions. Now, if I am going to create another group, and we will decide, oh, let's not follow their convention. Let's create our own. Okay? Instead of using X, let's use lambda. Is it wrong? Well, so as long as we agree and the concept is there, it's correct. So that's the cultural variation. So this is also supported by the social learning theory by Albert Bandura. So according to Albert Bandura, there has to be modeling. Okay, so usually or typically we learn by looking at the model. So that's the reason why when we teach mathematics, when teachers teach mathematics, we model how to solve the problem so that the students will follow. But how about in the case of Korean students? They were exposed to Korean education system of mathematics for so long, and then all of a sudden there will be a shift, right? So what will happen? Are they going to forget what they have learned in Korea and learn something new? So this is one of the interesting points that we can explore in this study. So what do they do with it? Okay, do they tend to forget what they've learned in Korea, their means of doing mathematical problems, or do they bring it with them in the Philippines? Okay, so some studies have actually explored, or a lot of studies actually explored the cultural underpinnings or the influence of mathematics, of culture in mathematics. So this is one example, a study that was conducted by Ernest in 1998. So according to him, mathematical knowledge and existence are rooted in the culture of mathematics, which depends on persons participating both publicly and privately to create and sustain it. So, likewise, mathematical knowledge in appropriately contextualized forms makes a central contribution to the creation of mathematical identity of persons as mathematicians. In this case, our high school students, Korean high school students. So with that, comes my interest to look into the cross-cultural experiences of the high school students. Okay, so now when we say cross-cultural learning, it is defined as an education that involves a mixture in which a student is made aware of his or her own and other cultures that comprise his or her education. This approach involves experiential education. So basically, when these Korean high school students was exposed to a mathematics curriculum in Korea, they have their own ways of learning it. Especially that they were taught in Korean language. Because language actually is a very important factor in the understanding of mathematical concepts. That's the reason why a lot of Filipinos could hardly do fractions. Why? Because fractions in English do not actually represent the actual partition of the fraction. Okay? Whereas in our vernacular, it's very easy, right? It's very easy. Okay, for example, I speak Cebuano. I taught a group of young students before in another school for an immersion program, for an extension program. So I asked them, what is 1/2 plus 1/2? They were just staring at me. 1/2 plus 1/2. They were just staring at me. I created model, they somehow understand. But when I said, katunga, punag katunga, they said, very fast. Yes, because they know. Yeah. And we cannot undermine this particular, we cannot undermine that. Okay, we cannot undermine that experience. Okay, we cannot say that the student is not good in mathematics. It's because the language maybe is a barrier. Okay, so now in cross-cultural learning, it is the process of adaptation to a new environment and its requirements through obtaining necessary knowledge, skills, and attitude. So what are the skills, knowledge, and attitudes that they acquire so that they could cross to a different spectrum of learning mathematics? So with that, I use Code's experiential learning model as my theoretical framework so that I would be able to evaluate this. Okay, so there are 4 phases basically: the concrete experience, reflective observation, abstract conceptualization, active experimentation. So this has to be in a cycle, right? So basically, it starts with a reflective observation. So now, for example, oh, this is how we did it in Korea. Now, they do it different way here in the Philippines. And then they eventually realize, and then they assimilate the Filipino way of doing it, of solving the problem. And then after assimilating that, they converge. And then they realize, they accommodate the new way of doing it until they realize that, oh, it is also possible. Our way of doing in Korea was just another way of doing it. But it does not mean that that was wrong. And that is going to open the understanding of the students towards mathematics, not just as a discipline, but as a discipline that is influenced by culture, that is influenced by the identity of the learners. So basically, this is the conceptual framework that I use. So we start with the experiential learning theory of Cobb, and then we triangulate the data using survey questionnaire, interview, and cross-cultural learning experiences in mathematics, and then focus group discussion. So in the focus group discussion, I'm intentionally picking students of the same abilities and the same profile so that they could share experiences. And then after that, the analysis of results, and then conclusions and recommendations, and the output of this is an inclusive mathematics education framework. Something that is responsive to the cultural differences. Something that is responsive to the identity of the children who are learning mathematics, especially Koreans. Okay, so according to Dr. Jean earlier, most of the times, Philippines is ascending country. Now we're a receiving, at this point, we are a receiving country. Now since we are a receiving country, we have to do something. And one thing that we can do is to create, since we are accepting Koreans in our schools, then we have to create an environment, a framework that is responsive to the cultural differences that they experience. Okay, we owe that to them the moment we accepted them in our system, in our school. So basically, these are the research problems or the research questions that I will be addressing. So what is the profile of Korean high school students in the Philippines in terms of migration and visa status, length of stay in the Philippines, mode of living in the Philippines, and exposure to the Philippine education system? Because some of them just exposed to the education system for 1 year. Some of them have different living arrangement. They're not living here with their family. They just live with in the dormitory, okay, as a high school student. So what are the main reasons why Korean high school students prefer to study in the Philippines? And what are the cross-cultural learning experiences in mathematics of the Korean high school students in the Philippines in terms of content, context, mathematical processes, learning materials, pedagogy, and learning environment? And I'm very certain that there are. For learning materials alone, there are so many studies already that have been conducted, especially in lesson study. Ms. Meg even conducted a study about that, the difference between the textbooks that are used in Japan and in the Philippines. Okay. So far in the initial conversations with the students, they said that there is really a difference, right? Philippine textbook is different from what they use in Korea. Okay, so for now, this is a working paper. So far in the initial conversations, these are the very prevalent answers of the students during the interview, and especially this was conducted during the training that we conducted. These were asked during the training that were conducted among Korean students who were participating in the Philippine Mathematical Olympiad and the Metrobank DepEd Math MTOP Math Challenge. So they said, I just learned that there is another way of solving it. It's different from what we were used to in Korea. And one said, the Philippine way of doing it is more difficult. Now, what is the thing here? Let the student do his or her own way. Because at the end of the day, what we're aspiring for is the correct answer, not the way how we did it. Right? So it doesn't really matter if the goal is to go to UP Diliman. It doesn't matter if you go through different roads, but the goal is to get there. And we have to understand that learners have different faces, have different cultural background, and they could not learn things in equal pace. So that's it. Thank you.